Hello students, hello students. In last lecture we discussed simple pendulum, and in first case simple pendulum in a lift. Okay, so now see the some MCQ of simple pendulum. See the first question. If length of simple pendulum is increased by 4%, if length of simple pendulum is increased by 4%, if length of simple pendulum is increased by 4%, then find percentage change in time period. Okay, if length of simple pendulum is increased by 4%, then find percentage change in time period. Chalo, see students, so it is very small change, 4%. So here we use the concept of error, right? Here we use what? Concept of error, because there is a small change in a length, 4%. Okay, so here we use the concept of error. See, what is its power? T is equals to 2 pi L by G raised to half. What is the power? T is equals to 2 pi L by G raised to half. So we write what, students? Here 2 pi constant, G constant. So we write what? Delta T by T 1 by 2 delta L by L. What is delta L by L? 4%. So what is the delta T by T? 2%. Okay, what is the delta T by T? 2%. Chalo, so percentage change in a time period is what? 2%, and percentage change in length is what? 4. Okay, delta T by T means what? Percentage error. Same as delta L by L is known as percentage change in length. So what is delta L by L? 4%. So what is the delta T by T? 2%, and that is known as percentage change in a time period. So now next question, students. Chalo. See, what is the next question for a simple pendulum? For simple pendulum, when length is L1, for simple pendulum, when length is L1, what is the time period? 4 seconds. And when length is L2, what is the time period? 3 seconds. When length is L1, what is the time period of simple pendulum? 4 seconds. When length is L2, what is the time period of simple pendulum? 3 seconds. So now length becomes L1 minus L2, then what is the time period? Now length becomes what? L1 minus L2, then what is the time period? So options are root 3 second, 1 second, Option C, root 3 by 4 second. Option D, clear. So what is the question? When length of simple pendulum is L1, what is the time period? 4 seconds. When length of pendulum becomes 3 seconds, when length of pendulum becomes L2, what is the time period? 3 seconds. So when length becomes L1 minus L2, find time period. So students, we consider here three cases. See, first 2 pi, what is the formula of time period for simple pendulum? 2 pi under root L by G. So first time period L, T1, length L1. Second case T2, time period L2, time period T2, length L2. So now we want to find time period when length becomes L1 minus L2. Okay, now we want to find time period when its length becomes what? L1 minus L2. So students, see, we can write here 2 pi L1 by G minus L2 by G, right? चलो, so now students, see, અહીંયા તમને દેખાય છે L1 by G and L2 by G. So find L1 by G and L2 by G from this formula. So for this, square on both the sides. So T1 square is equal to 4 pi square L1 by G. So T1 square upon 4 pi square equal to L1 by G. T2 square equal to 4 pi square L2 by G. So T2 square upon 4 pi square is equal to L2 by G. Right, so what is the value of L1 by G? T1 square by 4 pi square. What is the value of L2 by G? T2 square by 4 pi square. So what is L1 by G? T1 square upon 4 pi square, T2 square upon 4 pi square. So now students, 4 pi common. So what is the root of 4? 2. What is the root of pi square? Pi. 2 pi, 2 pi cancel, students. So what is the time period? T1 square minus T2 square. What is T1? 4 second. T2 3 second. So 16 minus 9. So what is the answer, students? Root 7 second. So students, you can remember when length is L1, time period is T1. When length is L2, time period is T2. So when length becomes L1 minus L2, time period is what? T1 square minus T2 square. Then time period is what? T1 square minus T2 square. Clear? So this is the final formula for time period under root T1 square minus T2 square. चलो next question students, see now see students, simple pendulum is placed in a lift. Okay, simple pendulum is placed in a lift. Simple pendulum is placed in a lift, and what is the time period of then what is the time when lift is stationary? Then what is the time period T1? What is the time period of pendulum? T1. Now lift starts accelerating upward. Now lift is moving upward with acceleration equal to g/4, with acceleration equals to what? g/4. Now find time period. Now find what? Time period. So options are 2t upon root 5, root 5t upon 2, done. So students, see simple pendulum in a lift when lift is stationary. Okay, what is the time period? See students, when lift is stationary, no pseudo force is acting on it. So in this case, what is the time period? T1, when lift is when lift is stationary students, no pseudo force is acting on it. So what is its time period? 2 pi under root L by G. Okay, chalo. Now in second case, lift is moving upward with acceleration A. So students, what is the formula of time period? તમને direct યાદ હોય તો what is the formula of time period? 2 pi under root L by G plus A. Right? Okay, no याद હોય તો જોવો proof કરાવી દે. See, mg is also down, mg is always downward, but now ma is what? Pseudo force is acting in a downward direction. Why? Because lift is moving upward with acceleration A. So what is the pseudo force? ma in downward direction. So what is the resultant force? mg dash. G dash is the effective gravitational acceleration. So what is the pseudo force? Now what is the effective gravitational acceleration? G plus A. So now what is the time period? L by G dash. And what is G dash? G plus A. Students, direct याद ज राखी लेजो. When lift is moving upward with acceleration A, what is its time period? 2 pi under root L by G plus A. When lift is moving downward with acceleration A, what is its time period? 2 pi under root L upon G minus A. Right? Chalo. So now what is the acceleration of lift? G by 4. So g plus g by 4 means 5g by 4. So 2 pi under root L by g, and 4 is in upward, so here we write root 4 by pi. Now students, this is what T1 original time period when lift is stationary. When lift is stationary, what is the time period? T. So 2t by root 5. What is the answer? 2t by root 5. Okay, so this is the final answer, 2t by root 5. Chalo. Now next students, this is very important and different question students. Time period of simple pendulum is T1, means routine formula 2 pi under root L by G. Chalo. Okay. Now next students, the point of suspension is now moved upward according to the relation y is equal to k t square. According to the what? Y is equals to kt square. Means this is the now point of suspension is moving upward according to the relation y equal to kt square. See what is the question? Point of suspension is moving upward with a relation where y is what? Vertical displacement in the y direction, t is time and k is constant. And what is its value? 1 meter per second square. And during this case, what is the time period? T2. And we want to find T1 square by T2 square. Okay. Chalo. And the options are G is 10 meter per second that we take, and see what are the options. 6 by 5, 5 by 6, 1 and 4 by 6 by 5, 5 by 6, 1 and 4 by 5. Chalo. So see students, how to find in first case time period is given 2 pi, right? Chalo. But in second case, what is the time period? Again, lift is moving upward with the relation y is equal to kt square. So students, see this displacement is changed with respect to time. Okay. So again it is moving with acceleration motion. So what is the acceleration in this case? Y is equals to kt square. So what is the acceleration? So first find velocity. Y is a displacement in vertical direction. So first find velocity velocity is equals to what? Dx by dt, but here y, so dy by. Now what is y? K t square, k constant. What is the differentiation of t square? 2t, है ना? Simple, multiply with the power. What is the formula of differentiation? Multiply with the power and 1 minus from the power. So what is the differentiation? So see, this velocity is also changed with the time. Velocity is equal to kt, so this velocity is also changed with the time. So it means velocity change, then the acceleration is produced. So what is the velocity? What is the acceleration? K constant, and what is the power of t? 1. So multiply with the power and 1 minus from the power. So 1 minus 1 0, anything raised to 0 1. So what is acceleration? K. Oh sorry, 2 kt, yeah? 2 रही गया है, it's a 2 kt. चलो, so what is the acceleration? 2k. And what is k, students? 1. So what is k is what? 1. So what is the acceleration? 2 meter per second square. So in upward direction, what is the acceleration? 2 meter per second square. So when acceleration is in upward direction, then what is the time period? 2 pi L upon g plus a. Right. In second case, what is in first case? Only what is the original time period? T1. Okay. Then point of suspension is moving upward with the relation y equals to kt square. So find acceleration. Then what is the acceleration? 2 meter per second. Lift is this point of suspension is moving upward with acceleration a. So what is the time period? 2 pi under root L by g plus a. Chalo, so now we want to find what? T1 square by T2 square. So square. See students, when we take ratio, then 2 pi cancel, length is also cancel. So first chalo write all the terms. So 4 pi square L by g. Here 4 pi square cancel, length cancel, so g plus a upon g. Now what is the value of g? 10. Acceleration to g 10. So 12 by 10. So 6 by 5. Okay. So what is our answer? 6 by 5. Clear students? So our question આવી શકે. Chalo, now students, next we discuss time period with the change in gravitational acceleration. Time period of simple pendulum, time period of simple pendulum on Earth's surface Time period of simple pendulum on earth surface is T1. Time period of simple pendulum at height 2r from earth surface is T2. Find T1 by T2. Okay, see students, what is the question? Time period of simple pendulum, time period of simple pendulum on earth surface is T1. Time period of simple pendulum at a height 2r, where r is what students? Radius of earth, right? So earth surface is T2, so T1 by T2. So students, here we consider two cases. First, see students, here G is changed, because when we are on earth surface, then G is different. When we at some height, then gravitational acceleration is different. So here gravitational acceleration is changed, so we can say that time period is changed, right? Chalo. So in a first case, time period of simple pendulum on earth surface. So first at this is at what? Earth surface. Chalo. So always distance are measured from the surface. So what is the distance? R. Right? Chalo. So what is the formula? T is equals to 2 pi under root L by G1. And what is the formula for gravitational acceleration, students? G1 is equals to Gme by r square, where r is what? Okay, this is the formula of gravitational acceleration, Gme by r square, where Gme what? G, capital G is a gravitational constant and me is what? Mass of earth. And small r is a distance from center. So but right now what is the location of a pendulum? At surface of earth. Okay, so what is its distance? Radius. What is its distance? Radius of earth. Chalo. So this is the first case. Chalo. Now second case. In second case, always students, height is measured from surface. Height is measured from surface and distance is measured from center. See, time period of simple pendulum at height 2r from earth surface. Okay. So and what is that? This radius r. So what is this distance from center? R plus 2r, 3r. So now what is the formula of time period? 2 pi L by G2. What is the formula of time period? Gme by, and what is the distance from center? R plus h. Okay, what is the distance from center? R plus h. And what is height? 2r. So Gme by 3r square. So Gme by 9r square. Clear students? Chalo. Now T1 by T2. So students, when we take ratio of these two, we want to find T1 by T2. So when we take ratio, then 2 pi LL cancel, and see gravitational acceleration is inversely proportional. So here T1, so here G2, here G1. What is G2? GME by 9R square. And students, here gravitational acceleration is different in both the case, because in first case pendulum is at the surface and next case pendulum is at some height. So okay, gravitational acceleration is changed with the height. So gravitational acceleration is changed in both the case. So what is G1? GME by R square. So GME cancel, 1 by 9 and roots. So what is the answer, students? 1 by 3. What is our answer? 1 by 3. Okay, chalo. Now students, next case we discuss, that is pendulum in a train. Okay, next we case discuss is what? Pendulum in a train or trolley, whatever we can say that. Chalo. In a first case, pendulum is placed in a lift. Now pendulum is placed in train or trolley. So now we discuss, students, what is the change in the formula. Simple pendulum is placed in a train or trolley. Chalo, so see students, now what is its acceleration? A. Okay, and this is our simple pendulum. Okay, this is our what? Simple pendulum. So what is the acceleration of train or trolley? A. Acceleration of train is what? A. So see students, train is in accelerated motion, so pseudo force is acting on a simple pendulum that is in opposite direction. So in that direction, pseudo force is acting on simple pendulum. In that opposite direction, pseudo force is acting. So students, right now how many forces are acting on a simple pendulum? Two forces, pseudo force and gravitational force. See, train is moving in that direction, so pseudo force is acting in opposite direction. So now this is our, suppose, sample pendulum. So this is MA, pseudo force. This is mg. This is what? mg. Two forces, F1 and suppose this is F2. So students, in a previous question, see the previous topic, students. In the previous case we directly add or subtract, because in a previous case means when pendulum is in lift, then both the force are in same direction or in opposite direction, so we direct add or subtract. But right now they are in different axes, one is in negative y direction, one is in negative x direction. So we want to find resultant force. So this is its resultant force, and what is the angle between them? 90, right? So students, how to find resultant force? F is equal to F1 square plus F2 square plus 2F1 F2, and what is the angle between them? 90. Chalo. So cos 90 is 0. What is F1? mg, but it's square, so m square g square, m square a square. And what is the resultant force? mg dash, where g dash is what? Effective gravitational acceleration. Okay, chalo. So what is g dash? Effective gravitational acceleration. Now students, from these two, m square is common, so g square plus a square. What is the root of m square? M. So m g dash so mm cancel. What is g dash? G square plus a square, so we write what? G square plus a square raised to half. G square plus a square raised to half. Chalo. So what is the time period, students? So what is the time period? 2 pi under root L by g dash. So, and what is g dash? G square plus a square raised to half. So students, this is our time period. This is the time period of a simple pendulum in a train or trolley. Okay, clear? So students, you can remember the formula. T is equals to 2 pi under root L by g square plus a square raised to half. Chalo. Now next case, students, pendulum in a car which perform with moving in a circular motion. चलो. Now next students, case 3. Okay, first case, pendulum in a lift, pendulum in a trolley or train, and then pendulum in car moving on a circular road. This is NCERT question students. Actually આ જે કેસ છે એક NCERT એડિશનલ ક્વેશ્ચન્સ છે સ્ટુડન્ટ્સ. તમે જોજો, એડિશનલ એક્સરસાઇઝમાં એક ક્વેશ્ચન છે આ, પેન્ડ્યુલમ ઇન અ કાર. Now you want to find time period of a pendulum moving in a car and performing what? Circular motion. So pendulum in a car moving on Chalo, suppose this is the car, this is the circular road. Okay, what is the radius of circular road? R. Now on this road this car is moving. Okay students, so see and in this car this pendulum is attached. Chalo. So students, always in a circular motion centripetal force is act. So centripetal acceleration is towards the center. So see here, towards the center centripetal acceleration, what is its formula? V square by R. Okay, why here we consider centripetal acceleration? Because it is, or centripetal force we can say that, F1 is what? Centripetal force towards center. What is its formula? mv square by r. And in a downward direction, mg. Okay, here again two acceleration. It is circular motion. So centripetal force towards center. So again two force, centripetal force and second mg. So this is the resultant force, this is the resultant force, and this is the angle between two force. Okay, so again two force, centripetal force mv square by r towards the center and downward mg. So what is the resultant force? Again same, f1 square plus f2 square 2 f1 f2 cos 90. Resultant force mg dash cos 90 0. What is f1? mv square by r, but it's square. So mv square by r, it's square. f2 is mg cos 90 0. Now square, so m square v square, m square v raised to 4 upon r square plus m square g square. So again students, m is common. So what is the answer? M square v4 by r square plus, now what is the root of m square? M. So g square plus v4 by r square. Right students? Chalo. M square root of m came. Then g dash is the effective acceleration. So what is the time period now? g square plus v4 by r square raised to 1 by 2. Students, આ ખાલી MCQ ફોર્મ્યુલામાં આવી શકે, ખાલી તમને ફોર્મ્યુલા પૂછી શકે MCQ માં, right? So these are the so this is the third case, and this is the time period of simple pendulum moving in a, now pendulum is placed in a car moving on a circular road. Then this is the time period of simple pendulum. This is the NCERT question students. Okay, actually આ question NCERT માં આપેલો છે તમને, right? Chalo, so students, now in next lecture we discuss pendulum. Pendulum is placed in electric field, then pendulum is placed in a fluid. Okay, two more cases, pendulum in electric field and pendulum in a fluid.